Good afternoon and welcome to Calculus in the PM. I'm your host, Ron Burgundy. Kind of a big deal. Now, we look here. Sine of x. I invented this. Sketch tangent lines to find the derivative of each trig function. So this is the function. Now, what's the easiest tangent line to come up with always? Zeros. Where does this function now? I didn't draw it quite perfectly, it's freehand, but where is there a zero? Right here, right? So I'm going to use a different color. I'm going to draw, there's a zero for the derivative, right? Agree? Where else do we have a zero for the derivative at? By the way, this is 2 pi, right? 0 to 2 pi, it's a sideways s for sine. So you can see, oh yeah. Right here. So if this is 2 pi, by the way, this is 1 pi. Pi halves, right? And that would be 3 halves, right? Okay. Three pi halves. Pi halves. Okay. That's the spot. You see how the tick marks work on this? Right out in 6, 12. I think I might have I made these up. Anyways, the thirds. Anyhow. What else can we do? Well, what do we know about the slope at this portion here? Positive or negative? Positive. Okay, so it's going to be going up-ish. What do we know about the slope between here and here, between the two zeros? They're going to be negative values. Okay, so kind of like a... What do we know about the slope from this zero and up? Positives, like when I say slope of tangent lines, right? Any guess what function looks like that and hits 0 at pi halves and 3 pi halves? It looks like the cosine. The slope right here, let's say it's 1, it is. And then the derivative of sine, I just heard that, is cosine. And then negative 1, it's its steepest right in the middle. And then positive. 1 there, okay. I wonder if I got this. Yeah, okay, I'm going to just, I was wondering if I could slip my blue function there, but I can't. Okay, I'm going to lock this down here because it's going to start. So, we know how to draw a cosine. It's a little flattish right here. And zoom down. Flattens out. Okay. Freehand, I have a hard time drawing on this board, but that's not too bad. I know I peaked a little early at the 2 pi, but. So what does this tell us? Just by kind of thinking about it, you can predict that the sine function's derivative is the cosine function. Yeah, it is. So, if we've got this, we can say, I guess I'll base it on the red drawing here, so I'll say dy by dx is the cosine function, cosine of x. Okay? Then you might be tempted to say, well, the derivative of cosine is sine. Not quite. Let's play around with it, though, and see what you guys can come up with. Same idea. Now, I didn't quite draw this nicely, but you see how it should kind of level out here. This is your peak. So what would the derivatives, tangent line, slope be at that point at the 0 here? 0. So we start with a 0 spot. Start with your zeros. Then the next 0 is at? Pi. Okay, yep. Horizontal line for the tangent. Okay. I used the wrong color though. I'm going to use a red. Okay, and at 2 pi we got a 0. Okay. You might be saying, well, that kind of does look like sine. But maybe not. So here's 0. And then it gets slightly what? Negative or positive? Negative. Gets a little steeper. It's steepest right here. Then it eases off a bit, right? Still negative, and then gets to 0. So it's negative that whole time. It comes back to 0. Then this section here is positive, right? What's this looking like?
Negative sign.
The negative sign function. Okay. So I was surprised nobody just said upside down sign, but negative sign is perfect, because that's what it is. So negative 1 there, positive 1 here. I'm going to sketch that in. I'm just trying to get my hand here. I have a hard time drawing smooth curves here. Doesn't look that curved, but you get the idea, right? So, the derivative of the cosine function is negative sine of x. From that, you can figure out everything else. Because do you guys remember from your, but you're going to memorize some of these things, but do you guys remember from your trig functions, everything can be broken down into sines and cosines, right? Tangent is sine of x divided by cosine of x, right? The reciprocal identities relate secant and cosecant, right? To tangent, or to sine and cosine. Secant is which one invert or reciprocal of secant is of the cosine. Okay. And they're cotangent and tangent are reciprocals of each other. So if you know these two, everything else falls in place. And those are the two basic ones. And I'm testing you on strictly Saskatchewan Calc 30 stuff. I'm going to stick to the basic 3 trig functions, okay? But when I'm testing you on the AP material, it'll include secants and stuff like that as well, okay? Now, I'm not going to make you do this, but that was just sort of a descriptive way of coming up with the derivatives, right? I include this because, well, they actually do something called the sandwich theorem and stuff. You know those, this is the definition of the derivative, right? You plug in sine of x plus h minus sine of x. You recognize that definition. Oh, Lordy, you think. Then you can expand this using one of those addition identities. I wouldn't expect you to do this often, but this is the proof. Then you can simplify it. And guess what? Remember those limits of h approaching 0? Sine of h over h, cos of h minus 1 over h. That's where those things come up, Adam, on that poster, right? They come to prove, if you need to prove the sine or the cosine's derivative. You don't need to prove that, though. But if you're a math kind of person and you want, like, how do you just come up with this? Because it's not like x squared and stuff where you can work things out. You got to do a lot of substitution. I don't know if you're interested or not. Probably not, and I'm guessing you're not. So, what do you need to know from this? What I've already told you. These things are important. Commit to memory. By the way, this thing with the u right now, don't worry about it until we have something called the chain rule, but just think of it as the cosine of something. When you do its derivative, it's the negative sine of that thing. And then this du dx thing, it'll make sense later. Okay? But this stuff right now is what we're talking about. We've got it. And we've already established that just by sketching. If you ever forgot, you could take a little sketch and figure that out, right? By finding out, oh yeah, cosine where my zeros are, sine where my zeros are, it looks like, and then go from there. So of course, Shindalka, that son of a gun, has to involve more than one rule at a time. Yep. Could have quotient rule, could have the product rule, and then eventually there's something called a chain rule. So, this is a quotient rule one, right? Let's give her beams. I'll go with green. I'm going to go with green. We're going to call this our f of x, just so I can use this notation. F prime of x equals So, by the way, on an AP test, they'll often give you a function. And sometimes if you don't want to rewrite the function, just say equals y or equals f of x, and then you can, once you've declared that, then you can use it throughout, right? So here I'm going to go f prime of x equals, well, what's the quotient rule in words? The derivative of the first or the top. So the derivative of sine of x. Cos of x. Okay? Leave the bottom alone. Subtracting the top left alone, the derivative of the bottom expression. The derivative of cos x, negative sine. What about the minus 2 part? Minus 0. So that zeroes out, right? It's a constant. So, well then, I'll put the minus sign first. And yes, what he was saying is, isn't it minus negative? But it's sort of separated. Now, the bottom, the denominator, is just squared. And that's just fine. I'm sorry, what's that?
I just write my derivatives first.
Okay, if it works for you, keep it going. I do it this way, I always go first top thing, derivative of top thing, leave the second thing or bottom thing alone. This way, when I say top thing or first thing, I'm thinking the only difference between this and the product rule is a plus or a minus sign, and the product rule never has a denominator like that, right? Okay. And then first thing left alone, or top thing left alone, derivative of the bottom thing, derivative of the second thing if you're adding for the product rule. Okay? That's the only reason why. You're welcome to do it that way. So, then, I'm going to drop the colors because we're just getting mixed now. Cosine and cosine, call it cosine squared, right? Not 2 cosine, it's cosine squared x. Minus, I'm distributing, right? So I did this multiplication, minus 2 times the cosine of x. So then, I've got minus 2 cosine of x. It doesn't multiply out to be anything other than that. Subtract, subtract. Subtract in a negative, so plus sine of x squared. Sinks. Sine of x. Don't call it sinks. The bottom, as is. And you can even see with our desired answer that we want, it has it as this expression squared, right? So that's good. But the top, where the devil are they getting 1 minus 2 cos x? I have a minus 2 cos x, but where am I getting a 1 from?
1 equals.
1 equals? Oh, what's that called? Pythagorean identity. You do need to know Pythagorean identities plural, but as long as you know cos squared plus sine squared of x equals 1, you can get the other ones if you need them. More about that if we need them. So, since we know this, 1 is equal to sine of x, sine squared of x plus cosine of x, you're going to replace, I'll just underline, this plus that, and you've got to make sure that there's a plus sign. They're both positives, right? You replace it with the number 1, and then we've got what we want. I promised you at the start, and I'm holding to that. Pythagorean identities you do need to know. You do need to know reciprocal identities. Secant is 1 over the cosine of x, etc. And you need to know the quotient identities. Tangent of x is equal to sine of x over cosine of x. Those are the ones you really need to know. The other ones, I haven't seen evidence that you need to know them. So I would trust that you don't. Okay? I wouldn't try to pull a fast one. Okay. Example, an equation to the tangent line of the graph of y equals x plus cos of x at this point, 0, 1 is. So this is like an AP question. It's a multiple choice one here. you need an equation to a tangent line, but first we need a slope. How do you get slopes of tangent lines? It's called the derivative, because the derivative is the formula that gives you the slope of the tangent. Let's do something here. Let's use this notation, y prime. It's nice and short. What's the derivative of y equals x plus cos of x? 1 plus sine. Ah, negative sine, okay. Might as well build that sine, S-I-G-N, sine, into the equation. Right? Sinks. Sounds like French. Okay, that's just a formula that gives us the slope of the tangent line to any point on this original function. We're wanting it particularly at 0, 1. They give us the y coordinate. They, I. So, what's the slope at 0? Well, we can plug this in. You can use this like f of x notation. Y of 0, y prime of 0 is equal to 1 minus sine of 0. And you happen to know, because sine of 0, that's just a brief memory aid, right? Sine of x from 0 to 2 pi, it starts at 0, right? So it's 1 minus 0. Y prime of 0 is equal to 1. That means the slope of the tangent line is 1. Already, I can look and eliminate, because when you're doing multiple choice questions, if you can quickly eliminate some choices, sometimes you don't have to even go further, but this one we do. But you can already see, okay, it can't be this one, if my work is right. It can't be this one. It's one of these three, though. I don't know. So, then I go back to the drawing board a little bit. Now I have to go y minus y equals mx minus x, right? So I'm going like y minus y1, 1 is 1, right? That's where I'm getting this. Is equal to 1 m x minus x1 minus 0 in this case, right? Okay. All of these are y equals, and they look like they're mx plus b form, so I got to solve. Y equals 1 times x is x. Minus 0, that's done. Plus 1 or minus 1? Plus 1 when we subtract the negative over. Okay, now we've got choice B. Now it's fast and easy when I do it, but I'm just showing you that those kind of questions, like AP questions, aren't necessarily tougher. But I would say that if you had a lot of time, if you're not like Calculus 30 students, they probably, you guys are going to learn some tricks to like go faster and stuff like this. But you could get over, you could probably get a 4 on that test if you really knew your Calc 30 stuff only, inside out. On the derivative stuff. The other half, though, the integration, you wouldn't. But you would know the first half of the course is the same as the regular calc course. It's just prepping you for this. Okay. Now, I'm not going to go through this too much, but it's not witchcraft or anything like this. The derivative of the tangent function, of course, it's built out of sines and cosines, and you can use previously known results. Bottom line that you guys want to know is the tangent function's derivative is the secant squared of x. That's all we need to know right now. So I can just say f of x equals tangent of x, f prime of x equals secant squared x. Of course, then it might be multiplied by something and so on. Similarly, here's all 6. Apply, cotangent, secant, cosecant. Now, I'm saying commit these results to memory. Why? Well, I'll give you these on Saskatchewan type evaluations, but on the AP ones, you're going to need to know them. So I'll just talk to you a little bit about them. People tend to know this. Derivative of sine is cos, just because it seems simple, and you use it the most. And the derivative of cosine is negative sine. They're kind of opposites. Now, think about this, some patterns for these derivatives. If it's a co-function, what do they all start with? What do they all have in common when you do the derivative? the derivative of any cosine, cosecant, or cotangent function will be negative. Answer. Okay? Now, do you see how sine and cosine are kind of related? Well, sine, derivative is cosine. Cosine, the derivative is sine, but with a negative sign. Okay? Tangents, derivative is secant squared x. Cotangents, well, it's automatically negative, but then instead of secant squared, it's cosecant squared, negative. Follow that? The derivative of secant is secant and tangent multiplied. Now look at this. What's the connection there? Instead of secant and tangent, we got cosecant, cotangent. So all you have to really know if you're going to memorize these is that the co-functions have negative derivatives. And this is more in Math 110 if you take it at university. You will need to have them committed. So all the co's are negatives. And then as long as you know, and I can almost guarantee you'll know these, just they're simple. But as long as you know what the sine, the tangent, and the secant are, do you see how you can come up with, well, the secant squared there? Okay, cosecant with a negative in front of it. The secant derivative, well, it's negative, and then instead of secant x tan x, it's cosecant, cotangent x. So you really see there's only three things kind of to memorize. And I would advise you to memorize them. It's not an intuitive thing to like, you would never memorize that the derivative of x cubed is 3x squared. You just kind of like work it out, right? You can't work these out, so you do have to memorize them. But rest assured that your chapter 3 test, you'll have this on a sheet of paper, okay? But go for it. And I gave you some answers for the evens down here. Work these, and do take the time to do these, because that's why I got you to hand those things in too. I know what happens is if you have the assignment in your hand, the hand in one, you're not going to do the practice on here, and you do need practice with these. So rip it up, man. Whip it up and rip it up. So